In this video, we are going to be talking about parallel and perpendicular lines as it relates to writing equations. So, when we're talking about writing equations, you'll remember there are really two quantities that we are particularly interested in. The first being the slope, right? And the second being the y-intercept. So we are particularly interested in those two things. In this topic, and when we're talking about parallel and perpendicular lines, we are particularly interested in discussing slope because that is kind of the important concept here. The y-intercept we'll kind of find like we've always found. So what we need to think about is we need to think about parallel lines and perpendicular lines and how their slopes are related. Parallel lines are super easy, and you may be able to kind of figure this out without too much extra work because parallel lines, they have the same slope. So if I have a line that looks something like this, and then I have a parallel line to that one, a line that's parallel to that one. We'll label this as line L, how about? And we'll label this, excuse me, as line M. It sounds like a good plan to me. So if I said that M is parallel to L, then M is a terrible idea. What am I talking about? That's never in a million years going to work because we use M for something else, don't we? That was a dumb idea. How about L and P? P will work better. P will work better. Element OP. So we got line L and line P. This says that line P is parallel to line L, right? So if that is true, then the M so let's say that the slope of this one is, I don't know, how about it's 1/2, right? Then this is for line P, by the way, right? Obviously, since it's purple, right? The slope for line L is, as you might already guess, it is also 1/2. And so that's the important concept here, and that is that parallel lines have the same slope. The two M's are equal, right? M1 equals, I should do this in a totally different color. Just go with straight up black color. That's a good idea. We'll do something kind of boldish. For parallel lines, M1 equals M2, right? That's the important bit here. So for perpendicular lines, this is our next idea. For perpendicular, I can write an N. Perpendicular. Okay. So for perpendicular lines, their slopes, I'm going to write the definition, and then I'm going to kind of do a picture with some actual numbers, and we'll get the example. So their slopes, if I have M1 as one of my slopes, then for my perpendicular line, it is 1 over negative M2. So to find the slope of a perpendicular line, we look at the opposite reciprocal. Okay. So that's what we're looking at there. So I like to say we flip and flip, right? So we flip the number over, and then we flip the sign as well. All right, so the opposite reciprocal. Let's look at kind of a more better example of this one, because unlike parallel lines, which are super duper easy to understand, perpendicular lines might be a little bit more confusing. So I'm going to draw me an axis right here. Okay. So there's my y-axis, of course. And then right here, we'll draw our x-axis. And let's make a line, and let's see if we can make something that's reasonable. Let's put a line that has a y-intercept of 2, and we'll make it have a slope like that, and I'll count it here in a second. So we'll keep our same color scheme, because why not? So we've got this line, and we're going to write the equation of this line. This purple line, its equation is going to be y equals 1 over 4x plus 2. All right. Now, so what I want to do is I want to draw a line that's perpendicular to this line. And I want to find what its slope is going to be. Let's give it the same y-intercept, because that's going to be easy to draw. 2, 3, 4. Okay. So something along those lines. That looks roughly perpendicular, doesn't it? Okay. So this line is perpendicular to that one. So what is its slope going to be? We're going to flip this one over. So if we take 1/4 and we flip it over and find its reciprocal, then we end up, of course, with 4 over 1, which equals 4. And then we also find the opposite of it. So the slope of this line should be -4x. And then we made our b the same on here. So this would be +2, right? So that's how we find a perpendicular line slope. We take the opposite reciprocal, we flip it over, and then we flip the sign. So see, that's flipped over, and then we flip the sign. It's really not a ton harder than parallel lines. It's just a little bit more than this one equals that one. So if we had an example like kind of what we've been seeing in these things, in all of our other examples where we're given like 2 points and we have to find the line, or we're given a slope and a point, we have to find the line. We might have an example where we want to write the equation Let me zoom in here a little bit. And if we're real lucky, actually the focus looks pretty good, doesn't it? Let's double check my focus. There we go. Sorry. There we go. All right. So we're going to write the equation of the line which, I don't know why I put that H over there. Who knows? Line which is perpendicular to -3x minus 2y equals 4 and passes through the point -1, 5. Okay, so we want a line that is perpendicular to this line and it passes through that point. Okay, so what we need to do first is we need to use this information here, that the fact that our line that we're looking for is perpendicular to this line, to find the slope. In order to do that, we need to figure out what the slope of this line is. So to do that, we're going to get this line into slope-intercept form. So I'm going to rewrite it below. So we've got negative 3x. Let's see, can we see that fairly well? Yeah, I think so. Negative 3x minus 2y equals 4. Right, so we need to solve this one for y. So my first step in doing that would be to add the 3x to both sides, right? So plus 3x and then plus 3x over here. These cancel, of course, leaving us with negative 2y equals, and I'm going to put this x term first just because that's the way we're used to seeing it, right? So I'm going to say equals 3x plus 4. And then we got to get rid of this negative 2. So it's multiplied times the y, so we got to divide both sides by negative 2. Divide this one by negative 2. Divide this one by negative 2. We don't really care about this term for this problem, but just for kind of completeness sake, we'll do that. This one cancels here, and we end up with y equals negative 3/2 x minus 2, right? Because 4 divided by negative 2 is 2. Again, we don't really care about this. So the slope of this line is negative 3/2. So our m is going to be the opposite reciprocal of this one. So the m that we're looking for is positive 2/3. Right? So we flip and flip. Right? So what we need to do now is use this along with this point to find our line. Now we've got a point, we've got a slope. You can either plug this into slope-intercept form like we seem to like to do, or you could use that kind of shortcut method and plug it into point slope, which is what I'm going to do. So I'm going to plug it into point slope here. Equals, and we're going to put our m right here, and then we're going to do x minus the other part of our point right there. So we're going to take and we're going to put our y part right here. We're going to put our x part right here, and then we're going to put our slope right here. Right? So then we're going to just solve this for y like we normally would. So we've got two negatives next to each other, so we're going to ka-chink right there. We're also going to distribute this 2/3. So I'm going to go ahead and take care of those on my first step here. Let me move. I guess you can see that fine. I was about to move that up, but looking at my screen, I think we're actually pretty good. So we end up with y minus 5 on this side. We haven't touched anything over there. So that equals, and then 2/3 times x is 2/3 x. 2/3 times 1 is 2/3, so this would be plus 2/3. And then we would, of course, add 5 to both sides. Okay, so these ones cancel. So then we've got y on this side, excuse me, equals 2/3 x. And then 2/3 plus 5 is 5 and 2/3. So this is the equation of the line we're looking for. So that's pretty straightforward. If we were doing one that was parallel, it would be the same steps. There's not really a whole lot of reason to walk through an example explicitly like that. If this had said parallel instead of perpendicular, then we would have just found this slope and we would have just used that exact number because parallel lines have the same slopes. And so that's really all we're adding to this. I know this is short. This is a kind of a partial lesson. We've already done most of this lesson in class. We'll see you in the next video or class. Bye-bye.